Hello, everyone, and welcome back to another episode of the Mining Experience, a live podcast that invites professionals from the mining industry to discuss new technologies, address challenges, and share work experiences. My name is Mohammed. I'm the marketing manager here at Promine, and I'm very glad to be here today. I'm going to be your host, and I'm here today with Uma, my co-host. Uma, how are you today?
Hello, Mohammed. Thank you. Hello, everyone. Mr. Ivan, I'm so delighted to be here with you in this episode of our broadcast. Umi Military's account executive at Promine, also a mining engineer and the military officer from Morocco.
Awesome. So today's topic, we're going to be discussing drift drilling and blasting, a very exciting topic. So when planning the horizontal development in underground mining, time, delivery, and cost play a fundamental role to have an optimal and efficient design. In this episode, we will discuss tools that can help make your underground horizontal development be productive. Our drift drilling and blasting module, part of the engineering category in Promine, facilitates the interaction between surveying and drilling design, thus achieving time and cost optimization. And these are the things that we will be discussing today.
So our host will tell us about the different organizational and prospective processes of drift drilling and blasting within the mining operation. In addition, they will also share with us their points of view on what is the added value that mining software provides to the profitability of optimal mining planning. Today, we really have the honor to host Mr. Ivan Dian, president of the company Promine, a mining and surveying software that serves over 100 clients in more than 10 countries. Promine also provides solutions for the geological exploration industry through its brand Geox. Mr. Ivan is a respected individual in the mining industry and has an extensive experience in programming, underground mining, and CAD-based software. He also has experience in research as he worked at the Noranda Research Center in Pointe-Claire, Quebec, in Canada. In his free time, he enjoys biking regardless of Quebec's weather. Hello, Mr. Ivan. How are you doing?
I'm doing very well. How about you?
Excellent. Thank
Great,
you.
Thanks. So, Mr. Ivan, if we are going to begin, I'm going to ask you this question. Can you explain to us what drift drilling and blasting is and which companies use it?
Basically, drift drilling and blasting is when you're making the first approach, basically to the ore body. So this is the first tunnel that you will basically do, and that will bring you to the paying basically part of the mine. Since this is on the critical part for a mining operation, this is very important, basically, that you go as efficiently as possible to that part. So drift drilling and blasting needs to go as quickly as possible from point A to point B, because everything waits for those tunnels to be ready. So it needs to be really done as quickly as possible.
Oh, I see. Okay. So I guess that's it's a very important aspect when it comes to underground mining. And what are some of the most important aspects that need to be considered in it for an efficient design?
Well, when you do this, there is a central part, basically, that you need to blast first, which we call the cut. And that cut design needs to be loaded with explosive, of course, but there are some holes that you will put in there that are simply empty. And basically, you also use what we call a rimmer to make those holes larger. So there is a way for the rock, which is broken, to expand. And that first part, all the holes are drilled close together. So you need to drill that with precision. And in some cases, if that cut doesn't work, basically that the explosion inside that cut doesn't pull the rock out, the rest of it will be wasted. So that's the very important part of that blast that you really have to take care of. Usually, if the cut works and breaks the rock correctly, the rest of the blast will just go fine. You won't have any other problems happening into that drilling.
Right. Yeah, and considering the fact that, you know, sometimes when we when there's an inefficient way to drill, we sometimes get whole deviation, right? So when you drill on a face, how do you make sure to avoid that deviation from drilling?
The first thing is your equipment that you need to really control in there, because if, let's say, the jumbo you are using is old and it's loose, basically, that's, you know, you cannot line up your boom always in the same direction for all of these holes, then these holes will start to go apart or together, and you don't want the holes to, you know, hit each other, because you get sympathetic blasting happening, and in this case it will break up the sequence of blasting. One thing in there is, depending on the type of rock, this will be blasted easily or not. Sometimes you need to put a lot of holes into a cut, especially when the rock is more plastic. This is more difficult than a rock which is brittle. So you need to put more holes in there, and there are more chances that deviation will make problem there. The miner, of course, is the operator of the jumbo. He is, of course, a big part of the equation. So when you drill your cut, don't put too much pressure onto the drill, because the more pressure you put in there, the more deviation will happen, and in this case, you are prone to get more problems in there. So good drill bits, and take your time. Don't rush it. Basically, those guys are paid very often by the advance, so they want to do this as quickly as possible. But in the case of the cut, yeah, be cautious and
Makes sense. Yeah,
follow a few rules there.
Absolutely. And when it comes to blasting afterwards, I guess the cost plays a huge factor in that, because of course you don't want to exceed the maximum cost associated with each face, and of course you have a limited budget for that as well.
Yes. And the cost of explosive is not, well, especially if you use ANFO, it's not that big, but you can save on explosive, especially in the cut, because sometimes instead of using loading the holes up to the face, you can load those holes a lot less, because the first hole you blast basically will make a crater in the face. There is a lot of rock that will come out around that hole, and very often the next hole will, you know, make that crater deeper and deeper. We did some tests, and we realized that after 3 or 4 holes, we were blasting holes one by one. After 3 or 4 holes, basically that crater is fairly deep, and it's even starting to take out some of the explosive, which was loaded basically close to the face. So you can, you know, leave some color in there, except maybe for the corner holes and the lifter, the holes that are at the bottom. In this case, it's probably better to let them being loaded a little bit more close to the color of the hole.
Absolutely. I think, yeah, Uma is back now. Yeah, okay. All right. Omar, are you still with us?
Yes, sure.
Okay. I believe you have both of your microphones open. Okay. Actually, you're muted now. Yeah, sorry about that.
Sorry for that.
No problem.
I have, now that we talked about the explosive, I have another question, Mr. Ivan. Like, personally, one of the stereotypes about the mining field is that people worry about using an excessive amount of explosive. If you can tell us, how do you identify the quantity needed to blast a certain, you know, length of the drift?
Okay. basically you will, of course, look at the diameter of the holes and how much explosive you put in there, and you can get a total in there. And the drift drilling and blasting module in Promine does all of that for you. So it's a fairly easy way to have an idea how much explosive you are using. Typically, the powder factor, the amount of explosive per ton that you are using in drift drilling and blasting, is fairly high because of the cut, basically, that has a lot of explosive in it. The cut, when you look at it, the first few holes that you use in the cut, they are blasting very small amount of rock. So you don't need a powerful explosive in this case. And we did some experiment with decoupled ANFO, and it works as fine as ANFO. And basically, you can have a very small amount of explosive basically in the cut to make it work compared to, let's say, the last holes that you do in the perimeter. In some rock, using more explosive doesn't help you, especially in sulfur, because you kind of melt the sulfur, and it's kind of stick basically in the cut instead of get out of the cut. So there is really experimenting to be done in that case to optimize. You go through quite a bit of trial and error. Sometimes your manufacturer of explosive can give you a hand. Basically, you know, it's it's their specialty. So you'll get some people in there that have a lot of experience that can give you a hand in this case. So there's always things that can be improved. Of course, when you look at the practicality of thing, bringing two explosive at the face is annoying, I would say, because miners will, you know, go for the most simple way to do things. So you always have to balance how much miners will follow your guidance in there too.
Yes, absolutely. So now, speaking of blasting, post a blast, how do you control the air quality when it comes to you know, having a sustainable mine to work in, and how do you avoid some incidents like rock burst, dislodging, or any other safety issues associated with anything, including the air quality of the after a blast?
After a blast, basically, the explosive fumes that you get, there is, well, CO2 that you need to purge, and some nitrous oxide, basically. And you have a ventilation tubing, which very often by law you have to have at a certain distance from the face. So when you blast, you have to, I would say, you want the ventilation tubing to be as close to the face as you want, but you don't want your ventilation tubing to be blasted, basically, so that it rips off.
Yeah, that's right. Yeah.
And basically you have to, you know, get another section and put it back in there, or repair it if you can repair it. So it's kind of a how you balance basically how close you can bring your ventilation tubing to the face, basically. So depending on the situation and the experience you have with your blasting, miners will say, okay, I'll move back a bit my ventilation tubing if they can do it easily. Sometimes, you know, it's on a cable and you can bring it back a bit in order to, you know, have it work once the blast is gone. One of the problems that are really problematic is if you're in sulfides, you can get a sulfide dust explosion, and that will burn everything in there. So this is usually a problem that is yeah, difficult because you may have to bring in the mine rescue team to put back basically the vent tubing in there, because the concentration of sulfur dioxide in the air is really poisonous. And basically you get in there and it takes no time before you feel bad, basically. So you need to really, take care of that with care. And you see right away that it will delay your production. It will delay your rate of advance per day and the production. So you need to really be cautious in this case to restore basically the working condition as quickly as possible, so that you can go and remove the broken rock and bolt basically the rock. Protection against rock burst is it's kind of difficult, but in some cases, if let's say you have some modeling of your faults and you have an idea of your rock quality and where things can get a little bit dicey, you could actually warn the miners in advance by doing that modeling, basically, which you can do in Promine, of course. Do that modeling, and then you can say, hey, next 3 rounds, be cautious, because you're getting close to that, either a rock contact, a fault, or some shearing, basically, which is in that area. And basically the miners, development miners especially, are really aware that the dangers which are in there, because they are the first one to go in there. There's no support, nothing, and they need to scale that area, and they need to make it safe for themselves. It will safe also for everyone, but they are the first one in there, so they have to make it safe for themselves. So basically, this is one thing that engineering can do: help them foresee the conditions that are coming by and prevent them that something could be happening in this case.
Thank you, Mr. Ivan. You pretty much covered everything. And my next question is somehow related to explosives as well. And just as you mentioned that it depends on how miners follow the instructions. So, like, how do you control all the explosives left in those drill holes on the face after the blast?
Okay. Basically, when you blast, very seldom the holes are going to be completely free of rock. So you have a little part of the hole which is staying in the face, which we call bootlegs, basically. So when the face was cleaned up and you get those bootlegs, there might be some holes that didn't fire, and there are actually some bootlegs which have still some explosives in them. The explosive in itself is not very dangerous, but since your detonator is at the end of the hole, the detonator is also in that hole. And this is really kind of, that's you need to be cautious. And the preferred method, of course, is water. So you use a spray of water and you wash basically the bottom of that hole as good as you can, basically. And by washing, all of that will come out of the hole. And by washing, very often you will disable you will render the explosive. AMFO will become, I wouldn't say inactive, but you cannot blast it anymore, basically, once it's wet. So so that way you make that part safe.
Yes, absolutely. Thank you very much, Mr. Ivan. So moving on to one more topic. How important is it to have a smooth workflow between the surveyor and the driller when it comes to design?
the surveyor, of course, what the surveyor wants to do is go to the face and measure it, basically, and show what is the current advance and where it's at. And since a surveyor is using an instrument, he needs to have, line of sight of the workplace, and he also needs to shoot some survey points which were implanted basically up in the drift, and so any equipment which is in there is in the way basically of the survey. Sorry about that.
No problem.
So basically the surveyor needs to show up once basically the rock has been removed and the place is secured. So there is support that was put in there, but he has to be there either before they drill, before the jumbo moves in and start to drill, or after the jumbo is done and has been removed. Of course, the surveyor could show up once the holes are loaded. That's not too much problem, but usually you try to stay away from something which is already loaded from explosive. So there is a coordination there, and usually surveyor will warn in advance that they're going to be there, and give a time frame. Basically, okay, I'm going to be there in the morning, probably late in the morning. So the miners will make some room so that the surveyor can go in there, make it as quick as possible, and so that the miners can move in and keep doing their job.
Yes, absolutely. It's very good that you brought up the concept of communication, because that helps with the scheduling as well, right? When you have that efficient communication, the schedule runs on time, and everybody makes sure to have the necessary resources to accomplish their task. So that's very well, yeah. And then when it comes to between so the same type of workflow, but now between the geologist and the driller when drilling in ore in this case, how do you assure to have a smooth workflow in this case?
When you drill in ore, it's a bit more complex because geologists need to go to the face and mark the ore limits, and basically the miners will adjust themselves according to those ore limits. So you try to have always the same thing happening at the same time in the day, so that the geologist that is showing up basically at that phase comes pretty much about the same time of the day. So in this case, it gets a little bit more, you try to have it scheduled like every day, a little bit always the same schedule, so that the geologist can show up and basically mark where the ore limits are. And very often he can give some directions. So if you do your modeling, let's say, like in Promine, you model basically the ore, the geologist could say, okay, that next round, take it a little bit more on one side, this side, so because the ore is going to turn that way in this case. So the geologist could, give some direction so that you're not missing some ore into that round, and that you have to take one slash on one side or the other side, and keep the following the ore with precision. So it's a bit of a different coordination in this case. Of course, it's not in all mines that you need to do this. Some mines, the ore is so obvious that miners will just look at, hey, this is the ore, this is what I need to drill, and they can just go by themselves and lay out their holes in there without having too much, without needing too much direction from geologists.
Thank you, Mr. Ivan. So nowadays that we are all seeking development, how is drift drilling and blasting different than before? Like, what are the technological advancements made in that?
Um, Back in the days, basically miners were having, chains that they would hang out from the back of the drift, look through two holes, washers actually, that were at the end of the chains, and they would mark the face. And from that mark, they would, go left and right a certain distance and up and down some distance. That was also giving them the slope that they wanted to follow. And nowadays, as we have a product which is called Promine Life Survey. Basically, the miners will set up an instrument, and they'll do a resection to, set the instrument position in space, and they will ask that instrument, hey, pinpoint where is, let's say, 1.5 meters above my floor and the center of my drift, and they'll just look at the laser, paint that, and the instrument will just go left and right, indicate where the walls are, and also mark the slope on the walls. So the miners will just, put a little bit of paint here and there, and off they go with that. And what is great about this is also that it brings back a actual survey of the drift to the engineering office. So you survey basically every round, and you are always up to date up to where you are. Of course, jumbos can be automated. Also, you can take, let's say, the design you did in Promine in drift drilling and blasting, and upload that to that jumbo, and basically the jumbo will, make sure that it drills everything according to the design. Of course, there's a limit that what can be done into that automation, especially when you are at the edge and some blasting didn't work well, so you have some rocks in the way. So somebody will have to, like move those holes a bit and change the direction to adjust it to the profile you want. Also, there is bootlegs that you cannot drill in, so somebody has to kind of go there and mark those bootlegs so that you don't drill into those previous holes because of the danger of if there is some explosive remaining at the bottom of these drill holes. So yes, technology can bring that to be more automated, but there are things that are a little bit difficult to do without a human being there and doing that job. So
yeah,
it's improving compared to, let's say, 20 years ago, but it will still be difficult to completely replace humans in this case.
yeah. It's interesting to see that that there's major advancements in this area, especially when you talked about live surveying and how you can almost automate that. So with that being said, do you think that drift drilling and blasting can be robotized in the future using no humans at all? And or would that be something too hard to do? It's interesting, yeah.
It's,
yeah.
Everything can be robotized, but in this case, we're working with explosives, and we're working with rock, which is not homogeneous. It's not the same everywhere. And there is always a moment where the explosive won't do what it's supposed to do, and rock will not behave how it's supposed to do. So there is exceptions that are happening every now and then, and you need to manage those exceptions. And this is where, of course, you can always improve, I would say, your program that handles this, but at some point, I think that the human brain has a definite way to solve things, a creative way to solve things. Because most of the time we think about, going in straight line somewhere, but at some point you get to some intersections, and basically you get faces which are uneven, and you need to, take a little bit higher, basically, because you plan to have some pipes or tubing passing on top of the drift. And when you get to those parts, it's a little bit more difficult to say, hey, give that to a robot, and making sure that the robot will do a good job.
That's interesting to hear that robots are still not smart enough as we are in the mining field.
Yeah.
Okay, so now my question is not to the mining expert, Mr. Ivan, but rather to the CEO of Promine company. How does Promine facilitate the use of drift drilling and blasting in its software? Like how we make it easy to modify the patterns and predict the effects of changes in drilling, loading, and also production?
Basically, the drift drilling and blasting module helps you create various designs, because every time you change dimensions, you need to create a new design with new spacing for the holes. And basically, the ground conditions will also ask for different designs sometimes. In some cases, you will alternate design between rounds to have the round, the cut basically on the left in one case, and next round to have the cut on the right. So you can create those designs quickly. Also, the loading part, of course, is part of that module. So you can actually compute how much explosive you need, set various annotations so that your design is actually clear to the miner, and that they look at it, okay, this is what I need to do, and this is the design I'm doing. If the miners are doing it or not, that's always the big question, but but at least you can try to optimize your design. Of course, when you know the number of holes, the amount of explosive you need, when the miners get the explosive, he can actually plan accordingly to bring the least amount of explosive to the face. If he's planning well, actually, he'll have the exact amount of explosive that he wants, so he doesn't have to bring back explosive to the powder magazine. The delays also. He has basically all the delays laid out that he's going to use, and in which hole goes which delay. So that's another thing that you supply with the design. So there is less, I would say, improvisation in this case, and you make sure that if you have a successful design, that it's always followed up. If you have somebody which is new on the job, of course, they can profit from that experience that you did with your different design, and they can start with that design right away and have a successful advance rate done basically with all of this information.
And when we talk about delays, that can also be done with Promine, right?
Yes. Yeah, you can set the delays, and you can use various type of delays. Of course, drift blasting is always using long delays compared to production blasting. So the delays have a longer period between them. So that's basically, I've very seldom seen people use electronic delays in drift drilling and blasting. And I don't think that it's necessary to go to electronic delays into drift drilling and blasting, because at some point you're always doing the same thing, and at some point when you use electronic delays, you need to program them, and that adds a step basically into the loading of holes and preparing the blast. So it's you may not be saving time when you want this to go as quickly as possible.
That's so amazing, Mr. Ivan. I would just like to take the opportunity and tell everyone that we are having courses this month about this particular module in 3 languages. So everyone is welcome to join us.
Absolutely, yes. Yeah. So Moving on to things that you can do with Promine in drift drilling and blasting. Reports are very, very important when it comes to drilling and blasting, of course, because it provides you concise information that can be used. And can you generate reports with Promine, and is it easy to use?
Yeah, we can generate reports. You can have the amount of drilling done, basically the amount of explosives, the number of delays, and you can get also performance issues also in there, like, okay, we're drilling 4 meters, but we break 3.7 meters in there.
Right,
So
yes.
you don't get kind of a total tonnage in there, so you can have an idea of your real powder factor in there. And basically that reporting helps you find out, oh, is there something we can improve? And then you can compare your design together in order to get the best out of it.
Thank you, Mr. Ivan. So, as we all know, surveying plays a huge role in well-designed drill hole pattern, as you mentioned. Can you tell us more, how does Promine facilitate surveying in drift spaces?
Okay. When the drilling part is basically the part where you need to have a good alignment, and this is basically difficult when, let's say, you are in a ramp and you're turning, and at some point basically the Promine Live survey will show you basically how you should basically orient your holes in there, where you should, place your drilling. And sometimes, especially in a curve, when you cannot turn the boom and it hits the wall, you need to kind of, okay, I'm going to drill this hole a little bit outside. It's going to make kind of a jagged wall, but at least I'm going to be inside that profile. So we can adjust that. And we'll even show basically the holes which are inside the curve. You need to drill them shorter. So we basically will show, okay, you should use this distance because of that face you have in front of you. So the face can change basically every blast, but the program will really adjust according to the current phase. And this is great because this is something which is very difficult for a miner to kind of look at. Okay, we're coming from here, we're turning that way. How should I orient this to follow along and follow that slope also that we have? And what are the lengths and direction of holes I should use in there? Unless you have a very experienced miner that, it can figure this out well, you will have, bumps in the walls, and to say at some point the face is not going to be perpendicular to the direction you want to go, and you need to adjust. But the PLS program will figure this out on the field, right when you are there and you plan those holes, and you get indications on how to do your things. So that way, you somebody which is starting to do that drilling and blasting has a really helping hand to get this figured out for him, and he doesn't have to, take his plan and measure some things up and say, okay, should go like this or maybe like that, and next round it's worse, and at some point they need to stop and okay, we're going to take a couple of slash years to correct this before we keep going on, and this blocks your productivity in there. So that helps a lot basically to have this this tool to help you.
Yes, especially that in a mine, there are usually a lot of rotation that is happening. So it's very rare when you get someone with 20 years of experience working on the same drift, same mine, So having that kind of tool is very, very useful, because it allows you to have an easy to use tool that anybody could really use, which is really great. Yes. Mhm. So before we continue on to the last question, I just want to remind everyone, if you have any questions, please leave them in the Q&A button in Zoom, or if you're watching us from Facebook, make sure to leave your questions or comments directly in the comment section. So, Mr. Ivan, lastly, we know that when planning, it's good to keep in mind that the first design won't necessarily be the best design. How easy it is to adjust your design in Promine as we, follow up in this question.
Okay. Basically, when you're not on grade or you have to correct basically those parts, what is important is where are you at right now, and adjust accordingly. So it's very with Promine Life Survey, you know where you're at, you know your floor elevations, your back elevations, and at this point you can go to the design part and say, hey, I'll add a point here and I'll set the elevation of that design. So you will get the new slope basically that you want to follow. Let's say that your floor is going too high or too low. And after that, you can just take this back into the Promine Live survey will get this automatically, and miners will have new lines and new floor elevations to follow in this case. So modifying the design is very easy things, but this needs to get as quickly as possible to the miners. And basically as soon as the miner will connect his tablet to the network, he'll get the new design in there. And basically the instrument is going to show the new lines to follow in this case. So that's really a very dynamic way to do things. Of course, it's not instantaneous because when you're at the face, you don't have a connection to the server and get the updated drawing. But the worst is one shift, basically, that will be using the previous design.
I see. Yeah, and of course, it comes with experience too. It's something that could be, it's repetitive, but it could be very well done with experience. And for everyone who's interested in live survey, as Ivan talked about it a lot, stay tuned, because we're gonna have its own podcast about this topic. Very, very interesting new tool. So make sure to follow us on social media at Promine Software to stay updated on the upcoming podcasts. So we have two questions, one in Zoom here. So from Alok Dwivedi. So the question says, what are the points we have to put in mind when we are blasting a decline?
Okay, water is really a problem. So you need to have pumping, and this can be a bit of effort to put in place, because basically when you go in a decline, if you want to drill the floor, basically it's difficult to get all of the water out. So most of the time you will use a water resistant explosive in this case, for your floor holes at least. Also cleaning up that bottom part, your heavy equipment will have trouble cleaning up, because you're going down and your floor is going down like this, and your bucket is trying to grab what's in there. And since your bucket is already at an angle like this, it's difficult to clean up the bottom part there. And you really need to clean up that bottom part, otherwise your floor will be always bumpy, because you're not drilling your holes close to the floor enough. So sorry about that, but a human being will need to go there with a shovel, basically, and remove some rocks. Of course, you don't need to clean the whole thing out. You need to clean where you're going to put your holes, so that you can put your holes at the bottom there easily. Apart from that, the rest is pretty much the same. Of course, when you are removing the rock, basically the scoop needs to go back up the ramp, and it's not very quick, usually going up a ramp 15%. So you need to plan some remuck stations. So a remuck is a place, a little part of a drift that you do. You take the rock out and you put that in the remuck. And at some point, the support guy and then the drilling jumbo will move in. And while those people are working in there, you go back with the scoop and you empty up that remuck so that you gain some time, because you can clear up the face for the next work, basically, to be done into that part. So that's something that you should always do, basically.
Absolutely. Yeah. Thank you, Ivan. Alok, I hope this answers your question. And we have one last question from Facebook from Emmanuel. Hello, watching you from DRC. Interesting topic today. Thank you very much, Emmanuel. Thank you for joining. And his question says, what are the required data before making that process? So I guess he's talking about the design in drift, drill, and blast in Promine. So he's asking about the required data to have before starting the design.
The rock you are facing is, of course, what you need to be really aware of. If you have a very competent rock and that is brittle, that breaks easily, things will go well. But if you have rock which is fractured or which is a bit more plastic, then in this case, it's not going to be as easy. But experimentation is the key here, because sometimes you would think that a given type of rock that you've been working with before will behave as planned, but it's not the case. Always start with more holes and more explosive than normally used, and then start to space the holes and make it bigger and bigger until you get big rocks in there, which are difficult to load up in the bucket of the scoop. So when you start, let's say you have a 2.5 inch, you could start with, let's say, 0.75 meters spacing, and see how it goes. If it goes well, then maybe, let's say, on the width of your drift, you can remove one hole and go a little bit more spacing. Same thing for the cut. You start with a cut which has, let's say, 4 or 5 rimmed holes, and then lower the number of rim holes, and put a little bit more space in your cut until when you look at the blast, you don't get a very good advance. So there is a lot of experimentation, and rock will play tricks on you. It's 1 month will go and, hey, that works really well, that's going to be our standard, and then boom, next 2 weeks it's pain in the ass, nothing works as usual. So you need to go back to your process. Okay, are we still doing the things we were doing as we have designed? If yes, okay, we need to change the design in this case. So it's always an ongoing process. There are some miners which are champions, basically, of this. They will learn their rock, and you go there, you cannot give them any clue on how to do things. They know it all, and they have figured out what's the best to do in there, and you have a lot to learn from those miners. Yes. So ask them questions, and go get some knowledge from them, because they're really good. Some of these guys are really good in there.
Absolutely. And we have one last question, again from Alok. What are the benefits to use the navigation in a jumbo equipment?
It will the jumbo will position itself, and that and your jumbo can be less than optimal where you position it, but the drill holes basically will be placed in the right spot. We can upload basically the drift, the design we do to the jumbo, and basically if we upload that to the jumbo, basically you can, go there, put it approximate and have an idea, but then the software inside that jumbo will take that drill hole design that you did and drill it in there, or at least have a good idea where the walls are located, what are what the slope is to follow. Some of those jumbos are very intelligent actually, and they do quite a good job.
Very good. Thank you very much for your answer, Mr. Ivan.
So if nobody has any other question, with this we conclude our podcast today. Thank you everyone for attending. Also, thank you, Mr. Ivan, for sharing your experience, stats, and allow me to say Promine with us. We appreciate you being here, and see you in the next episode.
Thank you very much, Ivan, for your presence. We really appreciate it, and it's glad to have you and to share your knowledge with us. It's very much appreciated. Thank you very much.
Thank you. Have a good day.
Goodbye.
Bye-bye.